Hi, everybody. My name's Steve Johnson. I'm a solution architect at AWS, and really happy to be sharing a presentation with you today. It's going to be about modeling and accessing application data efficiently using AWS Amplify. And the reason I like this topic so much is I'm going to get to talk about, you know, some of the questions a lot of our customers ask us. So I'm hoping by providing answers here, it'll be interesting for you as well, and hopefully something you can use in your own work. So this is a higher level talk. I'm not going to go too deep into detail about what Amplify is, other than to say Amplify is AWS's solution for doing web and mobile development. And in the Amplify suite of tools, we have three basic approaches to doing data access. We have the traditional REST API approach to doing data that's supported by API Gateway. We have API through GraphQL, which is supported by AWS AppSync, our managed GraphQL service. And we have something new called Amplify Datastore, which is a little different. It provides a local programming model that simplifies a lot of tasks in doing data access. And it's actually built on top of AppSync. So the first thing I want to do is just show you a feature comparison here. You'll see at the top row, we have the REST-based API access model. This is very mature. It's been around a long time. API Gateway is a really solid product, and when you pair it with Lambda, you have a great serverless solution for accessing your data. In fact, probably our most popular approach to doing this sort of work. Now, our mobile team a couple of years ago started thinking about data access in terms of what mobile developers might need, right? Mobile and web developers have some unique requirements. One thing we hear a lot is offline capability, because if you have a mobile device, or even if you're connected through Wi-Fi, if you lose your connection at some point, what happens next? If you're going to go on and offline again, and if you have a multi-user application where people are changing data, you need a way to do conflict resolution. So everybody is seeing, the ground truth. Everybody's seeing the most recent, most accurate set of data. And lastly, we wanted a way to work in real-time notifications, which is why Amplify API for GraphQL is based off of AppSync. GraphQL subscriptions handle real-time notification really well. Amplify Datastore takes that GraphQL approach and builds a lot more features on top of it, and also makes them easier to use. So we're going to take a look at, we're going to focus primarily on the AppSync solutions, which are the GraphQL API and Datastore. Okay, so regardless of what approach you take, there's a problem called the N+1 problem. Anytime you're building an app that accesses API data over a network, right? And the problem looks something like this. Let's say I have, a very inefficient application called the N+1 diner, and I want to find out what my customers want to eat, right? So what I might do is call an API that would get me a list of menus for a given location, wherever my customer is. And after I load the menu selection, they'll select dinner. And now that I know they want dinner, I'll make another API call that loads all the different entrees they can order, right? And let's say they select fish, and now we need to figure out what what sides or options are available for that entree. And you get the picture, right? Every time the customer drills down on data, you need to make another API call. Now, you may ask why, in this golden age of sophisticated hardware and infinite storage and fast networks, why is this such a problem? Well, it's a problem because of efficiency, and low efficiency is never a good thing, right? It forces a bunch of bad things to happen. First, is we're making more network calls than we want to. We're probably fetching more data from the back end than we actually need. And that increases latency, not just latency for the network, but latency for time to glass, right? Your customer experience takes a lot longer. If you're getting more data on the client, that also means that you need to process it on the client, which causes you to spend more battery and CPU, which is not a good thing. And you take all of these effects together in a cloud environment, it could also be more expensive. So you'll be charged for egress over, the increased amount of data you're pulling down. A lot of cloud services are priced based on requests or transaction count. And then if you're using something like Dynamo, read capacity units could end up being higher than you need them to be. So how do we mitigate this problem? Because as I said before, just about every application that uses APIs is going to run into this. And here's a couple approaches we're going to talk about today. First is caching. You can cache at the edge, you can cache at the back end. You can tailor your API design to match your use case. So in other words, you're trading off general purpose patterns for something that's specific to your application. The third item is getting really popular, especially among GraphQL developers, called batch loading, also sometimes known as data loading. So we can take a look at that. And lastly, you have the brute force method, which is loading all of your data onto your client, right? Which isn't as crazy as it sounds. And we'll get to that in a minute. So if we take a look at what I would call a standard GraphQL application, right, using the Amplify API, you'll see that we have a client using the Amplify libraries, talking to AppSync. And AppSync is going to pull data from our backend, from our data sources, using programs called resolvers. And if we're thinking about making this more efficient, I'm going to divide it up into three sections here. The first one is the client itself, right? The end goal is to get data on the client and the data that you need. So as long as that happens, you win, right? It's just a question of how it gets there and what's the best way to do it, and hopefully the least amount of work. The next area to take a look at is the GraphQL server itself. So GraphQL servers work by processing queries, much like a database, and then deciding how to select that data from the back end and shape it into the format that the customer requested. And there's a lot of efficiency in here that we can talk about. The last piece is the caching. AppSync has a built-in cache capability. You can turn it on with one click. And what that does is caches your back end, right? And with the hope that, if you make that data fetch faster, it'll make everything faster. Okay, so actually we're going to start with the caching. Let's take a look at what caching looks like in this environment. Okay, what you're looking at here is AWS Xray. It's showing us the trace for a GraphQL query. And if you take a look at the bottom, you'll see that AppSync is first going to look at the cache to see if there's a hit. In this case, there is not, right? So it knows it has to go to Dynamo. It fetches that data in about 23 milliseconds and then writes that data to the cache, which takes about a millisecond. Okay? So far, so good. Things are working the way we expect. Let's say I make the same request right after that, right? You'll see that I can go to the cache, I'm fetching the data in 1 millisecond, and I'm done. And this is great, right? The cache is doing exactly what it's supposed to do. It's taking your data, fetch operation down to a millisecond. You can't do better than that, kind of. So, but we got to look at the bigger picture here, right? Are we really saving a lot of time, right? Between 124 milliseconds and 140 milliseconds, that's good. But as we'll see, the overall time it takes and efficiency to get things done we need more than this, I should say. Now, obviously, this is fantastic if you have long-running resolvers, if you have resolvers that take, minutes to resolve or, tens of seconds to resolve. This is fantastic, but we're going to go a little deeper than this. When I talk to customers about using Amplify, especially the CLI, they will ask us about the data modeling that we use, in the CLI itself. And it works by taking a look at your GraphQL schema. And for every data type, we're going to build a DynamoDB table, right? So in our sample schema where we have, a blog database with blogs, posts, and comments, we're going to build a separate table for each one. And if we have customers that have used Dynamo before, or especially if they're really good at using Dynamo, they're going to try to optimize this right away, right? They'll be like, "Wow, that's a lot of tables," and they'll say, "Well, why can't we put it all in one table? Wouldn't that be faster?" And you can do this, right? You can use things like global secondary indices to build keys of different types of data. You can use projected attributes to give you basically what ends up being a database in a table, right? Does it make it faster? Well, it depends on your data access. Like I said, Dynamo is already pretty fast. And what you're trading off here is complexity of writing your resolvers, because now, your resolver logic really has to act like a database front end and start sorting through the fields in this table, whereas the general purpose table per type just lets you write code really quickly with excellent performance. So this is possible, but again, it might be doing some pre-optimization here. I would definitely think twice before doing this on large scale. Okay, when GraphQL first came out, the N+ problem was around and people thought, oh, wow, great. We have a GraphQL server that's going to efficiently do all this stuff and we don't have to worry about it. Yes and no. GraphQL does help quite a bit because it takes care of the data access for it. But most reference implementations of GraphQL will fetch data something like this. So if I have a query that lists all of the data in my database, it's going to do list all the blogs. And as it cycles through each blog, it's going to identify the posts that are associated with it. And then it's going to realize that post has comments associated with it. And it's going to start running queries in a depth-first fashion in a lot of cases. And this is not terribly efficient, but it's because in many cases, GraphQL implementations, when you run a resolver, the only context you have is the immediate parent, right? So if all you have is the immediate parent information, you'll end up doing this depth-first search, right? And it can get very inefficient for very wide trees or very deep nesting of your data, right? So that by itself, you should always manage your complexity and try not to make things too sophisticated in terms of depth or width, because, no matter what your solution is, you have to address that work. So in this case, we'd be doing 5 queries to get this data. And we could probably do better if we take advantage of the fact that we already know, all of the posts we need to fetch before we fetch any of them. And we already know all the comments we need to fetch before we fetch any of them. So when you work with batch loading, it would look something like this. You take the initial blog, the root type, then you know all the associated posts and you can fetch those. And you know all the associated comments and you can fetch those. So instead of doing, onesie, twosie queries, you can actually do batch queries or batch loading, and that's where it gets its name from. So I'm going to show you a demo now on how to implement batch loading in AppSync, sometimes called the data loader pattern after a very popular JavaScript library that does, the same thing. We're going to be using Lambda functions and batch invoke to make this happen. So let's see how we can use the batch invoke feature of Lambda to do batch loading of our data for a GraphQL query. So we're going to start the way we usually do with a schema. As you can see here, I have a blog type and a post type. Blog is related to post by a one-to-many relationship. And the idea here is to run a query that is going to dump the entire database. So you'll see here I'm listing all the blogs and the associated fields, as well as all of the related posts and their fields. So let's start off by creating a resolver for list blogs, which is going to return an array of blog posts. So if I go down here to the list blogs operation, I'm going to open up the associated Lambda function. And as you can see, this is pretty straightforward. I'm going to build a DynamoDB query that's going to scan the table and look for all the blogs. But I'm also going to run the result set through this prepare properties function, which is going to format the data the way AppSync expects it with the correct labels, as well as passing back an empty array for the posts here. We're going to do a batch invoke to populate the posts as part of this query, and I'll show you that next. As I mentioned before, we have a separate resolver for the posts field here. So let's go to that Lambda function. This is the one that's going to be batch invoked, as you can see here. And let's take a look at what the Lambda source code looks like. Again, it's not terribly complicated. When you batch invoke a Lambda function, you will send it an array of values, and you will get an array of responses in return. This is exactly what we want for batch loading of data. Instead of having, AppSync send the post resolver a single key and having it fetch that one key, we're actually sending it a batch of blog post IDs. So when we start fetching from the post table, we get back all of the posts associated with all the blogs instead of traversing the tree depth first. Okay, and then of course we hand the arrays back to AppSync, which will assemble it correctly. So let's take a look at our query here and see what happens. Okay, so this is the Lambda function, and they're a little cold because this is the first time I run it today. If I run it again, it goes a lot faster. And as you can see here, I'm getting my list of blogs. I'm getting all of my posts. Let's see if we can make that a little easier to read. There you go. And all the content for my posts as well. Okay, so 2 places to go look. You can look at the blog post, which I've provided a link for at the end of the slides. And you can also take a look at the advanced use cases in the AppSync Developer Guide. So I just want to make sure I give a shout out to my friend Sergey Onofrenko, who's certified AWS solution architect. So thanks for the blog post. It's referenced here on the slide and also at the end of the deck. The next approach to batch loading we're going to look at is the way Amplify Datastore does it. As I mentioned before, Amplify Datastore will cache the backend database on your device. So this has a lot of advantages, including instantaneous data access once it's cached on the device. But it's only really practical if the housekeeping is taken care of for you. And by housekeeping, I mean if anything changes on the back end, that has to be synced with the device. If you go offline, you need to start queuing mutations or changes to the data so you can send it back down to the server when you connect again. And doing the conflict resolution we talked about, right? So fortunately, Datastore does this for you. So loading the data on your client is practical in some use cases, right? And I'm not saying it's the silver bullet, but it's a very nice option. that I hope you'll take a look at. So we have a demo here of using the same data set to implement a Datastore implementation.
So now let's see how Datastore tackles the N+1 problem. Like any GraphQL solution, we're going to start with the schema. As you can see here, we have our sample blog schema. And you'll also see that this schema is decorated with transforms like the model transform, connection, key, and all of these help the Amplify CLI build your backend resources for you. So I prefer doing Datastore through the Amplify CLI tools. And to do that, you need to build a GraphQL API project. You'll pass it an annotated schema like this one. And you'll also select conflict resolution for the back end. And this helps Datastore, well, obviously do conflict resolution on your data. Once you push it to the cloud, you'll have your DynamoDB table set up, one per type, as we mentioned before. It'll take care of all of your resolver logic, and that resolver logic is implemented using VTL templates that talk directly to Dynamo. Before we saw how, we wrote Lambda resolvers, which are really great and flexible, but for speed and efficiency, the VTL is a lot faster. So that's a nice feature of Datastore. Once it's deployed, you're going to run some client-side code generation. And just like the backend uses a GraphQL schema, Datastore builds a client-side schema that contains all the model elements that it needs to do synchronization and offline and those types of things. So you can see here we have, a blog model, a post model, and a comments model. And as you can see here, each model has metadata associated with it, and each individual field has metadata associated with it. And because this is automatically generated, it makes the libraries a lot easier to use. So let's take a look at how we actually use Datastore. This is a React object. I'm using Ant for the layout and the GUI elements. And Datastore applications are Amplify applications. So you will import the Amplify libraries as well as the configuration file generated by the CLI, and then configure the environment. And this is all done in one line of code here, which is really convenient. For Datastore itself, we're going to import the client-side model types from the models directory, and we're going to import the Datastore library, and we can use predicates as well. So Datastore allows us to do fairly sophisticated queries, and but we're just going to start with the basics here. We're just like the previous example, we're just going to pull in all the data we can, right? This is what the interface for this simple demo looks like. I've got the developer pane open so we can see the data come in. And each one of these buttons will query the associated model element from Datastore. And I say from Datastore because once these are initially loaded from the back end, they are cached on the client, and you access that cache every time you do operations. Now, this is convenient only if you also have a library to take care of synchronization with the back end, offline, online problems, and general maintenance of the data. And fortunately, Datastore does that, right? So I can work with this data as if it was local to my machine, because it is. And the Datastore libraries will take care of the synchronization and offline for me. So let's take a look at what the code looks like. You can see here, I'm just doing a basic query on blogs. And if I go over here, click the button, it's going to bring in all of the blog data. So I happen to have 19 blogs in the database at the moment. And same way I can pull in posts. I've got almost 1,000 of those. What's nice about Datastore is I'm not just getting posts back here, I'm also getting a fully hydrated reference to the parent object, right? So this, even though this is the post object, I'm also getting fully populated model object. So this makes it a lot easier to navigate or filter data when you're navigating relationships. And of course, I can do comments as well. I better close that down because there's a lot of comments. So there they are, almost 10,000 of them. And once again, these comments will have fully hydrated references to the parent post right here. Just a couple other things I want to show you really quick. In addition to doing, the full query of all the data, I can also get an individual element here. So I'll just save that. And you can also do filtering like I'm doing here. If you, let's say you want to get all the posts associated with a blog, you can do it this way. So I'm just going to modify this code just a little so I get the filtered data. And I think it's already refreshed, but let's make sure. And if I click blogs now, you'll see I asked for one by key, so I'm only getting one blog back. If I click posts here, I'm only going to get the posts associated with that blog, right? So these are all Elastic Container Kubernetes blog posts, as you can see. So in a nutshell, Datastore does a lot of things for you automatically, which makes it super easy to build your client-side stuff. And having the data locally takes care of a lot of the pain of constantly fetching data.
So let's wrap up what we've covered so far. With respect to modeling data, there's a couple things I like to suggest to our customers. The first is, you do have options, right? There's no silver bullet for any of this. Some of the things I talked about today, I'm sure customers are like, this is the greatest thing ever. And some of them are like, I can't imagine ever using that for my use case. And that's fine, right? So just be aware of the options and start out with a good guess about which one of these is the best fit. I will say the defaults in the Amplify products are good, general purpose, scalable solutions, right? Hopefully, some of the data we looked at, even if it isn't micro optimizing all sections, of data access, they are good solutions. They're generally fast enough for general purpose, and you can always tweak them, through caching or tailoring or some other customization to make them, even more performant. Alongside of that is, the usual admonishment: don't optimize before you have data. Figure out where your bottlenecks are before you start changing your architecture. It's always good to get something working first, look at where it's slow, and figure out how to speed it up. And so let's talk about Amplify. Again, it gives you choices of how to do your data access. You can do REST, you can do GraphQL, you can do Datastore. And Amplify supplies a lot of other features too. In your web and mobile apps today, we just talked about data access. But we're going to be making a lot of announcements at reInvent this year around Amplify and the supporting products. So keep an eye out for those. There's going to be announcements about everything I talked about today, like new things that improve your developer experience and your customers' experience. And once again, thanks to Sergey for his Medium article. And I hope you get a chance to try this out yourself, because it really it's really an elegant solution to a tough problem. If you're looking for other Amplify resources, we have the slide here. We have a website, docs, tutorials. Amplify clients and the CLI are open source, and we have a very active community of developers who are supporting that, including our own mobile and web product teams, of course. And you can talk to us on Discord. And if you have any bugs or feature requests, you can put them on GitHub. The product team monitors those constantly. And that's our presentation for today. Thanks a lot. I really enjoyed talking about this with you. I hope it's really useful for you. And you can look me up at LinkedIn. And it would be really great if you could complete the survey for me when you're done here and give us a chance to do better next time. Hopefully, it was already good, but your comments and honest evaluations are always really appreciated. So thank you very much, and enjoy the rest of reInvent and our presentations. Thanks.